Hey guys, and welcome to another video from our sorting algorithm series. In this video, we'll take a look at the counting sort algorithm and how it really works. So we're going to divide this video into two parts. In the first part, we'll take a look at a step-by-step worked example of the counting sort algorithm, visualizing how it actually sorts an array of numbers. All right. And in the second part, we'll actually take a look at the code for the counting sort algorithm, which we'll also share with you. All right. So let's get into it. So this is the list of numbers that we're going to be sorting, all right? Now, a little background on the counting sort algorithm. For one, it doesn't compare between values, all right? It doesn't compare the values in this array to each other. So that's why counting sort is not a comparison-based sorting algorithm, all right? That's one thing that you should know. Secondly, the counting sort algorithm is a bit different in its code because it actually has a bunch of different smaller phases rather than just one main logic, all right? So this is why the explanation will be a little long, but pretty simple, all right? So I'll just explain things as we proceed, all right? So basically the first step that we have to do is actually create a new array, all right? And this new array must be based off the maximum value over here, all right? And in this case, the maximum value is 10, okay? So what we need to do basically is create 10 plus 1, an array of size 10 plus 1. So whatever the max size is, whatever the maximum element is here, we need to find that first and then create a new array of that size, plus 1, okay? And this is actually the result. You see, this is our array to be sorted, and this is that new array that we made, okay? And it has values, or more like slots, from 0 to 10. They look like 10 slots, but they're actually 11, okay, if you count, because 0 is also over here. So we have 11 slots in total. Okay, now what we're going to be doing is what we call counting. Okay, we're going to be counting the number of counts for each number. So what we do basically here is that we have the number 8 over here, right, in this array. So what we're going to do is begin iterating over this array, and then for every instance of a number, for every time we encounter a number, we increment the count of that number here in this array. Now that sounds a bit confusing, all right, but let me just begin and actually show you. Alright, so the first number over here was 8. So what we did was increment the 8 slot over here, right? In the 8th index, okay? So that's what we did over here. Now the next number is 1, alright? So what we're going to do is increment the value at index 1, okay? There we go. Now the next value is 3. So we're going to increment the value at index 3. Next value is 5, okay? Next value is 2. Next value is 0, all right? Next is 10, okay? Next is 2 again. So now we end up with a total of 2 counts over there. Now we have 5 again. So we have 5 incremented here as well, okay? So this is step 2 carried out, right? Step 1 was creating the array, and step 2 was the counts. Now we have step 3. Step 3 is like the summation of all these counts, okay? So what we're going to do basically is find the total number of counts. We're going to slowly go past, we're going to iterate over this array now, okay? And we're going to sum all the counts in it in a cumulative format. If you've ever studied cumulative graphs, all right, this is exactly what it looks like. So what we have to do to get this cumulative values is to add the current index, okay? Like let's say that we have 1 selected, okay? What we're going to do is add 1, the value at 1, into the value at the previous index, okay, which is also 1. So that will give us the answer 2. And then we're going to assign this back into the index 1. Okay, so index 1 now holds the value 2. You'll understand what's going on once we're done. Okay, so let's begin. I'm using this orange mark to display the currently selected value. There's no index before 0, alright, so we're going to ignore this. Okay, now the value of 1, the value at index 1 has changed to 2. Okay, that's because it was 1 plus 1. And now it's 2 over here, okay? Now same thing will happen once we move to index 2. Okay, it's going to add the value at index 1, which is 2, to its own value, okay, which is also 2. So we'll get 4. Then the same thing will happen with 3, we get 5. The value at index 4 is 0, so no change, okay? Then we have index 5 over here, which has the value 2. This gives us 7. There's nothing at index 6 and 7, so no change. Okay, then we have 8 over here at index, we have 1 at index 8, so that gives us 8. No change at index 9, and then we get 9 over here. Okay, and a quick way to check whether you've done this correctly is to just take a look at the last element over here. It's supposed to be equal to the number of elements in here. Okay, there are 9 elements. Okay, so there can only be a total of 9 counts. Okay, so if the value over here and the number of elements over here mismatch, then you know you've done something wrong. Okay. Alright, so let's move on to the next phase. And here is actually the main counting sort logic, alright, which we're going to use to actually put these elements into their sorted positions, alright. So what we actually do first is create a new array that you can see over here, okay, and its size should be the same size as the original array, okay. And the reason behind that, of course, is that you need to have an equal number of slots for the number of elements, right? So if you have 10 elements, then you need an array of size 10. Or in our case, we have an array of size 9, all right? There are 9 elements in here, so we need an array of size 9, all right? Which is what I've created here. I've also done the first step over here, which is placing 8 in its correct sorted position. All right, so let me explain exactly what's going on here. How did the value 8 end up at this position? Well, what we're basically going to do is begin a new set of iterations over our original data array and begin sorting them one by one. Now, the value 8 is the first one here, which is why it's the first one that gets sorted. So let's see what happens. Well, we're going to look at the 8th index of the counts array. This is where the counts array actually comes in handy, right? This is what we've been preparing it for. So we're going to look at the 8th index of the counts array. Why the 8th index? It's because we're looking at the 8th value right now. Sorry, the value 8. If we were, for instance, iterating over the value 5, we would look at the 5th index of the counts array. But right now we're doing 8. So we're going to look at the 8th index of the counts array. It sounds random, but it's a whole formula that's used to actually sort this. Now, we're going to look at the value at the 8th index, okay, which is also 8. Then we're going to subtract 1 from this, and then we're going to get 7. Now, 7 is now the correct index of the new array in which we need to put the value 8. It sounds weird, but this is how it works. Basically, let me repeat that. We take the value 8, okay, then we look at the 8th index over here in the counts array. We look at the value at that index, we subtract 1, and then we place the value 8 at that index, at that new index, 8 minus 1, in the new array, okay? And then there's actually one more thing that we have to do, which I'll also explain as we actually proceed. We basically decrement the count at the 8th index in the counts array, okay? This is actually an important thing. I'll explain as we proceed. Okay, now let's move on, and I'm sure you'll understand this as we actually do this over and over again, and as we actually take a look at the code, which is also pretty explanatory. Okay, now next up was the value 1, which gets placed over here. So how did that happen? Let's review the steps. Okay, we had the value 1 over here, and so we basically take a look at the first index, okay, not the 0th index, the first index, okay, in the counts array, and it has the value 2. Okay, so what we did was 2 minus 1, and that gave us 1. So we put the value 1 at index 1 in the new array. And then, of course, we decrement the count in the original counts array, right? Next up is the value 3. So let's try solving this first. Okay, so basically 3. Let's take a look at the index over here. Okay, this is the 3rd index in the counts array. And what's the value at this index? It's 5. Okay. So 5 minus 1, that gives us 4, and this means the value 3 should go at the index 4 over here. And yep, it does. Okay, and then of course we decrement that over there. So now it's 4. Next up is 5. Okay, it has the value 7, so 7 minus 1, 6, it'll go over here, right here, at index 6. Now we decrement the value at index 5, so now it's 6. Okay, so next up is the value 2 in the original array. So basically, what's the value at index 2 over here? 4. 4 minus 1, that gives us 3. So we're going to put 2 at the 3rd index, okay, so now it's over there. Then decrement the value at index 2 in the counts array, okay. And next up is the value 0. So what's the value at the 0th index in the counts array? 1. 1 minus 1, that gives us 0. So we'll put 0 at the 0th index, okay. And then, of course, decrement its count. Next up is 10. What's the value at the 10th index? 9. 9 minus 1, 8. That gives us the 8th index, right? So we put 10 at the 8th index, and then, of course, decrement its count. All right, so now we have 2 and 5 left. Okay, I actually deliberately put them at the end because there's something special over here that I want to discuss. The reason that we've actually been decrementing all these counts over here. Now let's imagine for a second that we hadn't decremented the value at 2. Okay, let's say that it was still 4. Okay, because we've only decremented it once, right? So it was originally 4. Of course, and it's decremented because we've already put 1, 2 into this new array. All right. So basically, imagine that this is 4. So basically, I saw 2 over here. So then I'm like, what's the value at the index 2? So then I thought, okay, it's 4. 4 minus 1, that gives me 3. But that's the index of an already occupied slot. 2 is already in the third index. So this is actually the reason that we've been decrementing the counts, because now this is 3. So basically 3 minus 1, that gives us 2, and then we put 2 at the second index, okay, like this. And this is what we've been doing so far, all right? And then of course we decrement the count once more. There's no point in decrementing it now, of course, because there's no repeated value, but of course we just need to do it. All right, so the next value is 5. Okay, again, same scenario. All right, if we hadn't decremented 5, we would have ended up putting it at the same slot. Okay, and this empty slot over here would remain. But right now we have decremented it, so now it's 6. So basically 6 minus 1, 5, and so we put the value 5 at the 5th index right here. All right, and basically we're done. This is our sorted array. So here's the code for the counting sort algorithm. All right. Now I've actually divided it into different stages over here, so you can easily see and match it to the slides that I showed you earlier. Here we have the creation of the array, the counts array. You can see using the maximum value. We used the built-in function for that, max, and then we just plus 1, and then we created that. Okay, this is list comprehension actually. It's the technique that we use to create it. And then over here, basically, we found the counts, okay, the individual counts. And this is a very, very simple code. And then here's the cumulative sum counts, okay. We added the previous index and the currently selected index. And we actually begin from index 1, okay, because if we began from index 0, this would be 0 as well, and that would give us minus 1, okay, which we do not want, okay. So begin from 1. Okay, and here's the sorting phase. And again, I've already shown you this before. This is the code for the creation of a new array. Okay, we take out the length of the data using the inbuilt function len, and then we create an array of that length. Okay, and then in the end we return that array. Now I'm going to run this code actually because I've actually left print statements at key points in the code. Okay, so I want you all to actually see that. Okay. So what's this? If you've actually been paying attention, you'll know that this is the empty array that we made, okay? And it should have about 11 elements, okay? Let's see, that's 5, that's another 5, and that's 11. Okay, so let's just recap. Why is it 11? Because the maximum value was 10, okay? So 10 plus 1, and that makes 11 slots, okay? And then we do the counting, okay? This is the print, okay? We printed the count array after the counting part. So we can actually see that for every number we have a count over here, right? And then here's the sum counts. Okay, and these values actually, now that I notice it, are actually a bit different from the ones we used earlier. So that's all right. You can actually just use this as a new example, okay? And let's see, all right? Turns out there are only 8 values over here, which is why we end up with 8 over here, okay? And we end up with 8 values over here as well, okay? 0, 1, 2, 3, 5, 8, 9, 10, okay, that's sorted. So yeah, I think we're done here. There's nothing else to really look at. So if you're actually interested in learning about other sorting algorithms that are probably faster than the counting sort, okay, because counting sort is fairly fast, but there are other options that can be better in other situations, like quicksort, merge sort, heap sort, radix sort especially, which is really good for numbers, all right, lists of numbers. You can actually check them out because they're all part of the same series, all right, as this video. So if you want to be updated and get to know about other content, make sure to subscribe, right? And I'll probably see you in a later video.